The implementation of California's new energy code has sparked both praise and criticism. While it aims to address the state's energy concerns, its strict regulations have raised concerns. The new code recognizes the unchecked growth in energy consumption. This surge strains resources and contributes to environmental degradation. By imposing more energy-efficient building standards, the code aims to mitigate this issue. Another key consideration is the finite nature of fossil fuels. Global oil production has reached its peak and is now declining. This means that society cannot indefinitely rely on fossil fuels to meet its energy needs. Given these facts, the code's stringent measures are seen by some as necessary steps to address an impending energy crisis. However, others view the code as overly restrictive, arguing that it will impose unnecessary burdens on businesses and consumers. The code prioritizes conservation measures, such as improved insulation and energy-efficient appliances. While this approach reduces demand, it does not resolve the issue of declining fossil fuel supply. Critics argue that the code should also consider investing in renewable energy sources to supplement dwindling fossil fuel reserves. Critics also raise concerns about the economic impact of the code. They argue that compliance with the new standards will increase construction and operating costs, potentially stifling innovation and making housing less affordable. Proponents counter that the long-term savings from reduced energy consumption will outweigh the initial costs. The debate surrounding California's new energy code highlights the challenges and complexities of addressing the world's energy crisis. While the code aims to promote energy efficiency and reduce fossil fuel dependence, its strict regulations have drawn both support and criticism. Balancing environmental concerns, economic considerations, and the need for sustainable energy solutions remains a multifaceted challenge. It is important to understand the context of energy codes in general. Firstly, energy codes are a set of regulations that establish minimum energy efficiency requirements for new and renovated buildings. Secondly, they aim to reduce energy consumption, lower utility bills, and decrease greenhouse gas emissions. Thirdly, energy codes are typically developed and enforced at the state or local level, although some countries also have national energy codes. The purpose of energy codes is to promote energy conservation and sustainability in the building sector. By setting minimum energy efficiency standards, energy codes encourage the use of energy-efficient building materials, designs, and technologies. This can lead to significant reductions in energy consumption and greenhouse gas emissions, as well as lower utility bills for building owners and occupants. Energy codes typically cover a wide range of building components and systems, including insulation, windows, lighting, heating, ventilation, and air conditioning. They may also include requirements for renewable energy systems, such as solar panels. Compliance with energy codes is typically required for all new construction and major renovations. Building departments and other regulatory agencies are responsible for enforcing energy codes through plan reviews, inspections, and other means. There are a number of different energy codes in use around the world. Some of the most common include the International Energy Conservation Code or IC, which is widely used in the United States, and the Model National Energy Code for Buildings or NEC, which is used in Canada. In addition to these model codes, many states and local jurisdictions have developed their own energy codes. The development and implementation of energy codes can be a complex process involving a wide range of stakeholders, including building owners, developers, contractors, manufacturers, and energy efficiency advocates. There's often debate about the appropriate level of stringency for energy codes, as well as the best way to achieve compliance. Despite these challenges, energy codes have proven to be an effective tool for promoting energy conservation and sustainability in the building sector. As energy prices continue to rise and concerns about climate change grow, energy codes are likely to become even more important in the years ahead. It is also important to consider the economic implications of energy codes. Firstly, energy codes can increase the initial cost of construction. This is because energy-efficient building materials and technologies often cost more than conventional options. Secondly, energy codes can reduce operating costs. This is because energy-efficient buildings use less energy, which leads to lower utility bills. Thirdly, energy codes can create jobs. The energy efficiency industry is a growing sector of the economy, and energy codes help to drive demand for energy-efficient products and services. There is evidence that energy codes have a positive impact on the economy. For example, a study by the American Council for an Energy Efficient Economy, or ASEA, found that energy codes in the United States saved consumers $19 billion on their utility bills in 2010 and created more than 300,000 jobs. Of course, there are also some potential negative economic impacts of energy codes. For example, some critics argue that energy codes can make housing less affordable. This is because the increased initial cost of construction can make it more difficult for people to afford to buy or rent a home. However, there are a number of ways to mitigate this potential negative impact. For example, governments can provide financial incentives to help builders offset the increased cost of energy-efficient construction. Overall, the economic impacts of energy codes are complex and depend on a variety of factors. However, the available evidence suggests that energy codes can have a positive impact on the economy by reducing operating costs, creating jobs, and improving energy security. Now let us talk about the benefits of energy conservation. Firstly, reduced energy consumption. Energy conservation helps to reduce the amount of energy consumed by individuals, businesses, and industries. This leads to lower energy bills and reduced dependence on fossil fuels. Secondly, lower greenhouse gas emissions. Energy conservation helps to reduce greenhouse gas emissions, which contribute to climate change. By using less energy, we can reduce the amount of carbon dioxide and other pollutants released into the atmosphere. Thirdly, improved air quality. Energy conservation helps to improve air quality by reducing the amount of pollution produced by power plants and other energy sources. This can lead to improved public health and a cleaner environment. Fourthly, increased energy security. Energy conservation helps to increase energy security by reducing our dependence on foreign sources of energy. By using less energy, we can reduce our vulnerability to disruptions in the global energy markets. Fifthly, cost savings. Energy conservation can save individuals, businesses, and industries money on their energy bills. By using less energy, we can reduce our monthly expenses and improve our bottom line. Sixthly, job creation. Energy conservation can create jobs in the energy efficiency industry. By investing in energy efficient technologies and practices, we can create new jobs and stimulate economic growth. Seventhly, improve building performance. Energy conservation can improve the performance of buildings by reducing energy waste and improving indoor air quality. This can lead to increased comfort, productivity, and health for building occupants. Eighthly, resource conservation. Energy conservation helps to conserve natural resources by reducing the demand for fossil fuels and other energy sources. By using less energy, we can protect our planet's resources for future generations. Ninthly, enhance competitiveness. Energy conservation can enhance the competitiveness of businesses and industries by reducing their energy costs and improving their environmental performance. This can lead to increased market share and improved profitability. Tenthly, sustainability. Energy conservation is an essential component of sustainability. By using less energy, we can reduce our environmental impact and create a more sustainable future for ourselves and our planet. Also, let us talk about renewable energy integration. The integration of renewable energy sources into the grid can pose challenges due to their intermittent nature. Energy storage solutions, such as batteries and pumped hydro, can help to address this issue by storing excess energy generated during peak production periods and releasing it when demand is high. Smart grid technologies, such as advanced metering infrastructure or AMI and demand response programs, can also help to balance supply and demand by providing real-time information and enabling consumers to adjust their energy consumption patterns. Grid modernization is essential for accommodating the increasing penetration of renewable energy sources. This includes upgrading transmission and distribution infrastructure, implementing advanced control systems, and developing new market mechanisms to support the integration of renewables. Government policies and incentives play a crucial role in promoting renewable energy integration. This includes feed-in tariffs, renewable portfolio standards or RPS, tax credits, and other financial incentives that encourage investment in renewable energy projects. International collaboration and knowledge sharing are also essential for accelerating the deployment of renewable energy technologies and promoting sustainable energy practices worldwide. This includes sharing best practices, developing common standards, and coordinating research and development efforts. Public awareness and education are crucial for building support for renewable energy and promoting energy conservation. This includes educating consumers about the benefits of renewable energy, providing information on energy-efficient technologies and practices, and encouraging them to adopt sustainable energy habits. In addition, we should consider energy-efficient technologies. Firstly, light-emitting diode or LED lighting. LED are highly energy efficient and have a long lifespan compared to traditional incandescent bulbs. They consume significantly less energy and produce less heat, making them a cost-effective and environmentally friendly lighting solution. Secondly, high-efficiency heating, ventilation, and air conditioning or HVAC systems. High-efficiency HVAC systems use advanced technologies to reduce energy consumption while maintaining optimal indoor comfort. These systems often include features such as variable speed compressors, smart thermostats, and improved insulation. Thirdly, energy-efficient appliances. Energy-efficient appliances such as refrigerators, washing machines, and dishwashers are designed to use less energy than standard models. They often come with Energy Star certifications, indicating that they meet strict energy efficiency guidelines. Fourthly, smart thermostats. Smart thermostats use sensors and algorithms to learn your heating and cooling preferences and automatically adjust the temperature to save energy. They can also be controlled remotely via a smartphone or tablet. Fifthly, insulation. Proper insulation is essential for reducing heat loss in the winter and heat gain in the summer. It helps to maintain a consistent indoor temperature and reduce the need for heating and cooling. Sixthly, energy-efficient windows. Energy-efficient windows are designed to reduce heat transfer and improve insulation. They often feature multiple panes of glass, low emissivity or low E coatings, and gas fills to minimize heat loss and gain. Seventhly, solar panels. Solar panels convert sunlight into electricity, providing a clean and renewable source of energy. They can be installed on rooftops or in open areas to generate electricity for homes, businesses, and communities. Eighthly, energy storage systems. Energy storage systems, such as batteries, store excess energy generated by renewable sources like solar panels. This energy can then be used when the sun is not shining or when demand is high. Ninthly, smart grids. Smart grids use advanced technologies to monitor and manage the flow of electricity, improving grid efficiency and reliability. They can also enable consumers to participate in demand response programs and use energy more efficiently. Tenthly, building automation systems or BAS. BAS use sensors and controls to automate building operations such as lighting, heating, and cooling. They can optimize energy consumption and improve building performance. Overall, energy-efficient technologies play a crucial role in reducing energy consumption, lowering utility bills, and mitigating climate change. By adopting these technologies, individuals, businesses, and communities can contribute to a more sustainable future. And also, building design is very important. Firstly, passive solar design. Passive solar design involves orienting a building to maximize solar heat gain in the winter and minimize it in the summer. This can be achieved by orienting the building south-facing, using large windows on the south side and providing overhangs to shade the windows in the summer. Secondly, natural ventilation. Natural ventilation involves using natural forces, such as wind and buoyancy, to ventilate a building. This can be achieved by providing operable windows, vents, and other openings that allow air to flow through the building. Thirdly, daylighting. Daylighting involves using natural light to illuminate a building. This can be achieved by using large windows, skylights, and light shelves to bring natural light into the building. Fourthly, green roofs. Green roofs are roofs that are covered with vegetation. They can provide a number of benefits, including reducing stormwater runoff, improving air quality, and providing insulation. Fifthly, cool roofs. Cool roofs are roofs that reflect more sunlight and absorb less heat than traditional roofs. They can help to reduce the urban heat island effect and lower cooling costs. Sixthly, sustainable materials. Sustainable materials are materials that are environmentally friendly and resource efficient. They can include recycled materials, renewable materials, and materials that are locally sourced. Seventhly, water conservation. Water conservation involves using water more efficiently. This can be achieved by using low-flow fixtures, collecting rainwater, and using drought-tolerant landscaping. Eighthly, energy-efficient landscaping. Energy-efficient landscaping involves using plants and trees to shade buildings, block wind, and reduce heat gain. This can help to lower cooling costs and improve the energy efficiency of buildings. Ninthly, compact building design. Compact building design involves minimizing the building's footprint. This can help to reduce the amount of land needed for development and reduce the environmental impact of the building. Tenthly, flexible building design. Flexible building design involves designing buildings that can be easily adapted to changing needs. This can help to extend the lifespan of the building and reduce the need for new construction. Overall, building design plays a crucial role in creating sustainable and energy-efficient buildings. By incorporating these design strategies, we can reduce our environmental impact and create a more sustainable future. It is also important to consider the future. Firstly, smart cities. Smart cities use technology to improve the quality of life for citizens and make cities more efficient and sustainable. This includes using smart grids, smart transportation systems, and smart buildings. Secondly, electric vehicles. Electric vehicles or EV are becoming increasingly popular and are expected to play a major role in the future of transportation. They are more energy efficient than gasoline-powered vehicles and produce zero emissions. Thirdly, renewable energy storage. Renewable energy storage technologies such as batteries and pumped hydro are becoming increasingly important for storing excess energy generated by renewable sources. This energy can then be used when the sun is not shining or when the wind is not blowing. Fourthly, energy efficiency retrofits. Energy efficiency retrofits involve upgrading existing buildings to improve their energy efficiency. This can include adding insulation, replacing windows, and installing energy-efficient appliances. Fifthly, carbon capture and storage or CCS. CCS technologies capture carbon dioxide emissions from power plants and other industrial sources and store them underground. This can help to reduce greenhouse gas emissions and mitigate climate change. Sixthly, hydrogen energy. Hydrogen energy is a clean and versatile energy carrier that can be used to power vehicles, generate electricity, and heat buildings. It is produced from a variety of sources, including natural gas, coal, and renewable energy. Seventhly, advanced nuclear energy. Advanced nuclear energy technologies such as small modular reactors or SMR and fusion reactors have the potential to provide a safe, reliable, and carbon-free source of energy. Eighthly, bioenergy. Bioenergy is energy derived from biomass such as wood, crops, and algae. It can be used to generate electricity, produce transportation fuels, and heat buildings. Ninthly, geothermal energy. Geothermal energy is energy derived from the Earth's internal heat. It can be used to generate electricity, heat buildings, and provide hot water. Tenthly, ocean energy. Ocean energy is energy derived from the ocean's waves, tides, and currents. It has the potential to provide a significant amount of clean and renewable energy. Overall, the future of energy is likely to be characterized by a mix of different energy sources and technologies. These technologies will need to be sustainable, affordable, and reliable in order to meet the world's growing energy needs.